Okay, today we're going to talk about squares and square roots. Get it? Square roots? Okay, so a square is a product of a number and itself. Here's an example of a square. 3 squared. The product of 3 times 3. A square root is when you're finding the number that can be multiplied by itself to get a product. So I might ask you to find the square root of 9. 3 times 3 equals 9. A radical is the name we use for the symbol to find the square roots. Sometimes you'll see a plus-minus symbol, and that indicates that there's an answer that's both positive and negative. They're looking for both answers. So if I ask you to find the positive and negative square root of 9, the answer is 3 and negative 3. Ever wondered why we call it a square? Because we're making squares. So if I have one square, each side is 1 unit. This is a 1 by 1. When we find the area of a square, we're multiplying the sides together for 1 square. I would say 1 squared equals 1. If I have 4 squares, each side is 2 units. So 2 by 2 will give me 4 squares. 2 squared equals 4. If I have an array that gives me 9 squares, each side is how many units? That's right, 3. 3 by 3. 3 squared equals 9. Each side is 3 units. Okay. Take a second and find these square roots. Okay then. If I'm asking 81 squares, what would the length of my sides be? I'm looking for 9, because 9 times 9 will give me 81. If I had 225 squares and I arranged them together to make a perfect square, each side length would be 15. I can take the square root of a fraction by breaking it up and finding the square root of the numerator and the square root of the denominator. If I have an operation under the radical, it's like a grouping symbol, like parentheses. I take care of whatever operation is first before I find the square root. But I want to add these instead of multiply. 5 plus 11 equals 16. The square root of 16 would be 4. I'm not always going to have a perfect square that I'm looking for. Sometimes I'm going to have a different number of squares that won't give me a perfect square, and that's when I'm going to have to estimate a square root. Only a certain number of squares can be arranged into a square. So if I were given 16 squares, I can put them in an array so that I have 4 units this way and 4 units this way. If I have 7 squares, they're not going to fit into a nice even number to make a full square. So I'm going to have to estimate based on what I know about other perfect squares. You're going to find the closest perfect square to get your estimate. If I ask for the square root of 7, I know that it's going to fall in between the square root of 4, which is a perfect square, and the square root of 9, which is a perfect square. The square root of 7 is going to fall in between the integers 2 and 3. And if you take a look and think about what this looks like on a number line, it's actually closer to the 3 than it is to the 4. Because in between these numbers, I would have the square root of 5, the square root of 6, the square root of 7, the square root of 8, the square root of 9. Let's go back and put the square root of 4 there. There's only one square root in between here and 2 in between here. Take a second and find which two integers the square root of 50 falls in between. Okay. The perfect square that comes before 50 is the square root of 49. The square root that comes after 50 is 64. Square root of 50 is closer to 49. This integer is 7. This integer is 8. So the square root of 50 is going to be approximately 7.1, somewhere around there. Just so you know which two integers it falls in between.